Hey, what's up, y'all? I'm Josh Marshall, and I got something special today. I've been a software professional for over 10 years now, and something I've been asked a lot is how do you always find the bugs so quickly? Now, I won't lie to you. Sometimes I'm just that good. See that right there? That's a class A7 Heisenbug. You want to look in that file there? Yep, right around there. There's the bug. But other times I might seem really smart. I'm really just using a foolproof technique. This technique has served me very well over my entire career, so I want to share it with you today. I'm going to show you how to find any bug with version control. So, a couple things to note here. This technique is really useful, but it's actually not my first choice. Usually, I find bugs a lot faster using the debugger and reading code. But when that doesn't work, this is a solid fallback. I don't always use this, but when I do, it always works. Another thing to know is that this technique can be used in any project and any version control. I'm going to show you how to do it with Unity and Plastic SCM, but this easily translates to whatever technologies you may be using. This guide assumes you already know the basics of your version control tool. But if you are using Plastic, make sure to check out my supplemental video. It'll be somewhere on the screen right now, where I'll show you exactly how to get a faster workflow in Plastic. Now, with those out of the way, let's get started. So I have a Unity project using Plastic SCM for version control. You're supposed to be able to talk to this character and to click dialogue options to continue the conversation. I created this scene months ago and it was working just fine. However, when I try to click it now, nothing happens. I already tried the usual debugging and nothing was making sense. So I decided to use one of my favorite methods for such an occasion. And believe it or not, you've probably heard of it before. Alpha team, to your left. Bravo team, to your other left. That's right. I'm talking about divide and conquer. If you want to learn more in depth, you can find all kinds of great resources by searching for divide and conquer. But for this video, all you need to know is that it's an algorithm that's often used for searching through sorted lists. It just so happens our version control is also a sorted list of changes. We can actually divide and conquer our version control history, but instead of comparing numbers at each step, we'll be checking for the presence of the bug. So what we'll do is start with a range of commits. We'll check the middle commit and see if we can reproduce the bug. If the bug is present, that means that it appeared either in the chosen commit or in an earlier commit. Otherwise, it means the bug happened in a later commit. Then we can repeat the same steps on whichever half the bug is in. Since we're cutting our range in half each step, we're going to find the culprit in no time. It's natural to start our range with the history of the bug's entry point. In Unity, the entry point for everything is a scene file. Here's the history of the scene where the bug occurs. We have some context that narrows down the range of commits we start with. The feature was definitely working in commit 537, and the bug was found in commit 678. Next, we'll look at the entire project's history and check out the middle commit. Ooh, check you out. At each step, we can exclude commits we've already confirmed. We've already confirmed 537 and 678, so our first commit range is between 538 and 677. We can find the middle commit by adding them together and dividing the sum by 2. So the middle commit here is 607.5, so we'll round down to 607. Wait. Now before all of you formula phobes go running away, you don't have to do any math here. You can just as easily guess the middle commit and it'll work just the same. Relax. We'll check out commit 607 and see if we can reproduce the bug. The bug also exists in 607, which means it appeared in this commit or earlier. Now we want to check between our existing low, which was 538, and our new high of 606. We'll repeat that process to get 572. Let's check out 572 and see if our bug appears there. Hey, it works in 572. That means the bug appeared in 573 or later. So this time we have a new low of 573 and we use our existing high of 606. And we'll basically rinse and repeat these steps until we've narrowed it down to our evil culprit. We'll check out 590. Not reproduced, so we'll go higher. Now we check out 599. We reproduce the bug, so go lower. Check out 594. Not reproduced, so go higher. Check out 596. Not reproduced. Just two more commits left, 597 and 598. Now we check out 597. Hey, there it is. Since the bug did not appear in 596, but did appear in 597, we know our culprit is 597. Ladies and gentlemen, we have a winner. Don't blame the president. Don't blame your parents. Don't blame it on the alcohol. Blame it all on commit 597. And I wouldn't have gotten away with it too if it weren't for you meddling coders. So now, by dividing and conquering, we now have the exact commit where the bug appears. If this commit happens to be small and deliberate, the bug will probably just jump right out at us. Now let's see here. 21 files. 50 million lines. Ah, man. Here we go again. This is just one of many reasons small commits are so helpful when reviewing changes. Big commits can be pretty scary, but I'll quickly show you how I hone in on the bug from here. The first step is to consider what files in this commit were used in the crime scene. Of the prefabs in the scene, only one file is present in both, the core game object. In this case, we have a prefab with many structural changes that aren't easy to make sense of in text form. So instead, I looked at the prefab in Unity at 596 and 597. I noticed a suspicious new transition object that has a canvas attached. If I'm right here, disabling this will fix the problem. That was it. So in the end, it was this transitions canvas that was blocking raycast required to click the buttons in Dialog Systems canvas. So the solution is to disable the transition after it does its job. And the final step is to politely ask your teammates to watch my upcoming video about why smaller commits are such a good practice. This particular issue was caused by unintended scene object interactions. I would have never found it in the debugger. That's where this technique really shines. You're guaranteed to find the bug, and it will generally be within 5 or 6 steps. So if you ever find yourself stuck on something and it's just not making sense, consider giving this a try. So if you made it this far, thank you so much for watching all the way through. But before you go, I want to know, what are some ways you like to troubleshoot? Let me know in the comments below. Also, let me know if this video helps you find any bugs. Don't forget to like and subscribe for more. And until next time, happy bug hunting.